Hi everyone, and welcome to Milestone 5. This is where we propose how to handle all the new data Ethermat is getting, things like click streams and chat logs that don't fit into our old MariaDB anymore. So our goal is simple. We are going to build a hybrid data architecture by integrating a specialized NoSQL database. This presentation will cover the uh, lake versus warehouses comparison, the new architecture, our NoSQL proof of concept, and the criticality, like whether it's safe or not. So moving on to the section one, data lakes versus data warehouses. So to start, we have to clarify the difference between a data lake and a data warehouse because they solve different problems and they are not interchangeable as well. So think of data lake as a huge, cheap, messy reservoir. So it holds all the raw unstructured data, sensor logs, social media feeds with no schema enforced. So we only figure out the structure when we actually read it. This is great for data science discovery. So the data warehouse, on the other hand, is the opposite. So it is highly structured like a library, clean, organized, and ready for reports. The structure is fixed before we write the data. This is where our key business reports live. They interact by having the messy row lake feed data that gets cleaned up and processed into the structured warehouse where it becomes useful for the final analytics. So all the differences that which I told right now are tabulated here, so you can see the differences between data lake and data warehouse in the table. So moving on to the uh, next slide. Hybrid architecture proposal. So this is the hybrid architecture proposal which I have made for the Ethermat database. I think it's not visible. So this is the diagram which I have proposed as a solution to solve the challenges that Maria and Alex raised on the use case. We are moving to a three-tiered system where every type of data uses the right tool for the job. Our MariaDB cluster stays the heart. It's the source of truth for all the transactional data like orders and products. But now the new data streams split off. Massive scale data like uh, IoT telemetry goes into our conceptual data lake for cheap long-term storage. Flexible semi-structured data like chat logs and complex customer profiles goes into our new MongoDB document store. This specialization means we are not trying to force a square peg into a round hole. We get performance, flexibility, and scalability across the entire organization. So moving on to the next section, that is specialized NoSQL integration. We choose MongoDB as our specialized NoSQL platform, and the core reason is its schema flexibility. MariaDB is great, but if we want to track a new customer preference, say their favorite smart device, we have to change the structure of the entire customer table. That's slow and also expensive and very time consuming. So MongoDB being a document-based database, that is, we can store as JSON-like profiles. So we can add a new preference field to just one customer's document without affecting the rest of the millions of profiles. So it is a perfect choice for the 360-degree customer profiles and storing unstructured chat logs. So moving on to the demonstration part, I've used the Milestone previous version for installing the MongoDB. First, uh, I have set up a MongoDB on a new EC2. I've used the previous one, that is Milestone 4 EC2 instance. So I set up MongoDB on a new AWS EC2 instance. So in this, I have installed the MongoDB And after the MongoDB is installed, we can see the version and all these things. So for connecting to the MongoDB instance, MongoDB, we are uh, using a keyword called mongosh on root. So once we enter mongosh, we are able to connect to the MongoDB. Then create, read, update, and delete. These are the performance things that we have tested on our MongoDB. So for that, we start by using the create thing. We create by uh, we start by logging the initial chat using insert one. Notice the transcript array in this. We are embedding an entire conversation history inside one document. So there is no complex SQL joins or anything is needed. We can directly insert. After that, we are able to use the uh, find custom db.customers.find to check if any. Here I am using first name as Betty, so it will revert all the details with the first name Betty. That is the read operation. So we use find to query for all documents where the status is open. So this allows a support manager to see their team's active workload instantly. So next we are going to use the update one. So this is the most crucial part. We use the special $push operator to just append a new message to the transcript array. We don't have to read the whole document, edit it, and write it back. This is incredibly efficient for live evolving data. So the last one is uh, deleting the data. For that, what we are doing is finally we have a simple delete one to remove the log when it's old and ready to be archived. We can use the find operator to verify whether it is gone for in the case of delete. For update, we are just verifying it if it's got updated. For reading, we can use the find to just find the customer which we have created using the read as well. So, that these are the operations which we are performing on this. So if we execute uh, those codes, we can see that it is coming as acknowledged true, and they are able to do the operation successfully. And for this also, we are able to find a customer ID with first name. And for this, we are updating the set value as we are settling the customer nodes value as interested in smart lighting, and push in tags. We are making it marketing target. So if we go to the code part, you can see what all tags are there. So in that, we are just updating another one. See, tags are smart home, early adopter. For that, in addition to these two, we are adding another tag called marketing target, and customer nodes also we are updating. So over here, we are able to find it. The last operation that we are doing is delete. So over here, I'll just drag this out. This is the last operation that we are doing. That is a delete operation. So we are using delete one command, and we can see that it is coming as acknowledged true, and deleted count is coming as 1. So these are the operations which we have done in this part. So moving back to the slides. Now we are gonna move to the security in heterogeneous environments. So security best practices for heterogeneous environments. So basically, Sarah Shen was right. Spreading data across MariaDB, MongoDB, and a data lake creates security challenges. So we can't have fragmented security. We will enforce three best practices. That is a network segmentation. That is every platform lives in its own secure AWS subnet, and they only talk to each other through strict minimum privilege security group rules. And another one is consistent encryption. We mandate encryption in transit, that is SSL or TLS between services, and encryption at the rest using KMS or database native features for all data regardless of its location. Another thing is unified access control. So instead of managing user list everywhere, we tie permissions back to a single identity provider. This ensures that when a user's role changes, their access is updated consistently across MariaDB, MongoDB, and the data lake. So this is the AI assistance and development reflection slide. So in this milestone, I've used both Gemini and ChatGPT large language models for the completion of this assignment. They were basically, I have used the help of ChatGPT and Gemini for generating the foundational technical theoretical concepts like lake versus warehouse definitions, MongoDB fit, and refining the professional CSS styling. Also for the root operations and specific contributions. If I say I have used the ChatGPT for the structure and the components and the visual flow of the complex, the architectural diagram. And also, AI helped me to develop the detailed data flow description and the platform-aware security controls, ensuring technical accuracy and details. Also, AI have helped me in assisting in creating the initial presentation outline and maintaining a consistent professional dark theme design. So if you ask me about the lessons that I learned as part of AI, I'm just moving it around so that you guys can see. AI has significantly accelerated the creation of the boilerplate technical architecture and professional styling. But I think even though AI will help us with all of the activities, but it's our human oversight and constant human intervention is required to ensure the technical accuracy as these things are really complex and critical. Security measures are also there. So all these things, human intervention is a great thing. Even though AI is able to give us responses, it might not be correct. So we only have to look onto it and take it whether it's right or wrong, and we have to debug as far as we can so that we will get a better solution. So, so assignment, in this assignment, I've used certain image sources, and I'm just keeping the image sources source here, and that's it. To quickly summarize the milestone, we are moving Ethermart to a true hybrid architecture. So we keep the strength of MariaDB for transactions while bringing in MongoDB to handle the complexity and volume of the unstructured data. This strategy ensures we maintain scalability, performance, and most importantly, a robust security posture across all of our growing diverse data set. Thank you. And once again, thank you for hearing my presentation. Hope you all are having a great day. Thank you.